This is David Tucker, and my course is our dark matter universe. Um, I got interested in this topic when I started spending time over at LIGO, a gravity wave observatory in Richland that looks for black holes. And so one topic that has really come up that's interesting now is the topic of dark matter. And the reason it's really interesting is because when you look up at the sky at night, you see the stars, but the real action now is going on. The surprising action is everything that's in between the stars, the dark area, because there's a substance up there called dark matter, and it takes up all the space in between that you see the stars. In fact, 85%, astronomers estimate that 85% of the total mass in the universe is this dark matter that we cannot see. And so for my class, I'm going to approach this from a mystery point of view, and meaning with the audience, we will go through evidence as to what we know about dark matter and what we don't know. So we're going to look at it from a detective point of view. Two things that we do know about dark matter is that it behaves like glowing matter and stars. It behaves with gravity. You know what gravity is, and so dark matter behaves exactly the same thing like that. By the way, that's one of the reasons why we think it's a particle. Somebody would think maybe it's a black veil or something that's not that doesn't have any mass, but no, this dark matter does gravity. Okay, and it pushes galaxies around. That's why I sent the two images. If you look in the images of those galaxies are being forced around in the universe by the dark matter. And another piece of evidence that's really good that helps us really believe that dark matter exists is because galaxies rotate. All of them spin on an axis, and we've calculated how fast they spin. And so, like a merry-go-round, a galaxy is acting just like a merry-go-round. It's spinning around and around and around. And you know that when it spins, the merry-go-round spins too fast, you would spin off and literally be sent right off the horses on the merry-go-round. Okay, and that is the problem with galaxies. We've calculated it. It's called angular momentum. We've calculated that, and the numbers just don't add up at all. Is that every galaxy in the universe should be falling apart according to those calculations. And so that leads us to believe that there's some hidden mass in there called dark matter, and it is literally holding the galaxies together. I just wanted to emphasize that if you take the course, you'll learn a lot about the cosmos and how we're able to even see galaxies in the first place. And we'll learn about stars in those galaxies. Let's see, we'll see. I have some new pictures that have come in from the Vera Rubin, the new Rubin telescope. Excuse me. That shows the entire universe, 60% of the visible universe that we can see now. These are unbelievable pictures that shows how all the galaxies are connected together. threads of both dark and um, visible star matter. Um, that's about all I have, and I want to emphasize that um, I always encourage questions, and it's the class will be non-mathematical, which means it'll be oriented towards just interested people who aren't astronomers. Um, that's all I have. Thank you very much, and hope to see you in the class.